welcome back to Simply Biology. In today's video, we're going to be looking at the factors which affect enzyme-controlled reactions. Now, if you didn't see the previous video on enzymes, what an enzyme is, it's a biological catalyst. It is also a globular protein. So what a catalyst does is it speeds up the rate of reaction by lowering the activation energy to allow more frequent successful collisions to occur between the substrate and, in this case, the enzyme. So there's multiple factors that we're going to study in today's video, including temperature, substrate concentration, enzyme concentration and the pH. So without further ado, let's get started. So we're going to be firstly looking at temperature. So between a temperature of 0 to 40 degrees Celsius, as you increase the temperature, the rate of reaction, this abbreviation just means rate of reaction, will increase since the substrate molecules will contain more kinetic energy and therefore will move at a faster rate. When the molecules move at a faster rate, they will collide more frequently with each other, and this will increase the frequency of more successful collisions. The more frequent successful collisions you have per second, the faster the rate of reaction. So, as I just said, that's between 0 degrees and 40 degrees for the majority of enzymes, or especially the enzymes within the human body. If you increase the temperature above the 40 degrees, this causes the molecules to vibrate, or the atoms in the enzyme to vibrate, and this will cause the destruction and the breaking of the hydrogen and the ionic bonds, and as a result the enzyme will lose its unique 3D shape. The shape of the active site, which is the part of the enzyme that the substrate binds to, will become denatured, and therefore it will be unable to bind with the substrate molecule, and therefore the rate of reaction will significantly decrease. So if you think of the temperature graph for rate of reaction as a bell curve. As you increase the temperature, the rate of reaction increases, but as you get past the optimum temperature, which is just the temperature which the enzyme works best at, it begins to fall off. The rate of reaction begins to fall down because the enzyme becomes denatured and the substrate is unable to bind to it. So the next factor we have is substrate concentration. So increasing the substrate concentration will increase the rate of reaction provided there are sufficient enzyme active sites available. So this just means if you increase the substrate concentration and there's excess enzymes which aren't binded to any other substrate, this will increase the rate of reaction. But it's also important to note that increasing the substrate concentration will increase the product concentration proportionally. So if you double the substrate concentration, you're going to double the product concentration. So when an enzyme, all of the enzyme active sites are occupied, this is when the enzyme is known as working at the Vmax, where V stands for velocity. And this is just a case where all enzyme active sites are occupied. However, notice how we said provided that there are sufficient enzyme active sites. So increasing the substrate concentration when there are insufficient enzyme active sites, this will not increase the rate of reaction because it will cause the rate of reaction to plateau, because increasing the substrate concentration doesn't do anything if there's not the enzyme active sites available in order to break those excess substrate molecules down. So if you think of a graph of rate of reaction against substrate concentration, increasing the substrate concentration will initially cause the rate of reaction to increase. However, once it gets to a certain point and where the substrate concentration goes beyond or is greater than the enzyme concentration, the graph will begin to plateau, because now what the enzyme concentration is known as the limiting factor. And now that brings us nicely on to enzyme concentration. So enzyme concentration is another factor that affects the rate of enzyme-controlled reactions. So if you increase the enzyme concentration, the rate of reaction will increase, provided there is excess substrate molecules. So this is just the reverse of what we've just been talking about. If you increase the enzyme concentration, provided there is excess substrate molecules available, this will increase the rate of reaction because there will be more frequent successful collisions between enzyme and substrate molecules per second. However, if there's insufficient substrate molecules or there's not an excess of the molecules, increasing the enzyme concentration will not affect the rate of reaction because there's insufficient substrate molecules, and then this is when the substrate concentration is known as the limiting reactant. So once the substrate binds, the enzyme site is occupied and it's unable to be occupied by another substrate molecule, if that makes sense. And therefore, the rate of reaction is proportional to the amount of substrate molecules and the concentration of the enzymes. So just to clarify that, the rate of reaction is proportional to the substrate concentration and the enzyme concentration. And when, like I just said previously, when all enzyme active sites are occupied, the enzyme is known as working at its Vmax. V stands for velocity. And the final factor we have that affects enzyme-controlled reactions is pH. So pH, you may have came across in chemistry. It is just a scale to determine how alkaline or basic or acidic a substance or solution is. So I've drawn out a rough sketch. It's between 1 to 14. 1 to 6 is acidic, 7 neutral, 8 to 14 is basic or alkalinic, because an alkaline is a soluble base. So another thing to note is when you move by a factor of 1 on the pH scale, so when you go from 2 to 1, the concentration of H plus ions, the acidity, increases by a factor of 10. And this is just the opposite for the basic side. So as you decrease, you get more acidic, and as you increase, you get more alkalinic. So the way that pH affects the enzyme concentration is that a high pH affects the binding of the R groups. Remember, the R group is a variable group attached to every amino acid. It affects the binding of the R groups to the active site of the substrate molecule. In addition, a high pH causes the ionic and the hydrogen bonds to break between the enzyme. Therefore, the enzyme loses its unique 3D structure, and it then becomes known as denatured because the enzyme active site changes. The substrate molecule is unable to bind to the enzyme active site. Thank you for listening to this video today, and I hope you've learned all about the factors which affect enzyme-controlled reactions. If you are unsure what an enzyme is, please refer to my other video about enzymes. Thank you so much for watching this video, and I hope you enjoyed it. Goodbye.